Stop talking and immediately start working the question. The minimum value of h for which the system has a tendency to rebound after hitting the ground. So both the blocks, no, they're released from rest. Both the blocks will descend. No. So they will, this lower block will descend an height h. So this is a reference because this is a natural length. We'll keep this as a reference for us. Now what is the state of both the blocks? Both will have velocity say v1, v1. And what is the condition given? Just after striking, the lower block will come to rest. Some inelastic collision it will take place and it is get fixed here. Is it fixed? No. Assume zero coefficient of for lower block and ground. What is telling? After impact, the velocity of that will become 0. It will lose all its kinetic energy to the ground and come to the rest. Not fixed here. E equal to 0 doesn't mean that fixed. Assume zero coefficient of ratio for lower block and ground. The minimum value of h for the system has a tendency to rebound after hitting the ground. It should rise up here. Only after impact, what is the state of the block? This will come to instantaneous rest here. And now because of velocity, what should happen to this block? It's going to move down. I think the same concept I'm repeating again. So it will come to instantaneous rest. What is the state of spring? Spring got compressed. The weight mg will be acting. It will come back to the same position with the same speed with the velocity directed upward. No, it has to rebound. Rebound means they should lose contact. Somewhere it will. Kx2 elongation. Then it is about to lose contact, no? The spring force will press the block, the weight mg, and say n1. Now here it is having a tendency to lose contact. Here normal reaction here will be, it will be 0. So the block loses contact here. Same previous problem. Only thing is this v1 we are going to bring by this h, that's all. So what height this will descend, the same height this will also descend. The same problem actually. All first three problems what I solved, all they are one of the same. For lower block to rebound, What is the necessity condition? Kx2 should be greater than or equal to mg. Minimum we are going for it. Then what is v1? Equal to root of 2gh. I'll write some things directly. mv1 square equal to mgx1 is equal to, from where I brought this equation, applying conservation of mechanical energy between these two. Here what is the form of energy? Kinetic energy of the block plus gravitational potential energy. That is what everything got converted into elastic potential energy of the spring. What is the state of block? Instantaneous rest, kinetic energy 0. I define this as 0 potential point, 0 gravitational potential energy. So what is the gravitational potential? Here will be 0. Here it will have mgx1. Next, again applying between these two. One more equation. So this will be kx1 square by 2 is equal to solving all this will get the minimum value of h. Okay, solve it. This will be answer.
Sir, I have a doubt, sir.
Yeah.
Sir, how are you assuming that the spring is at natural length before the instant it is hitting the ground, sir? It should be elongated, right, sir? At like when it was held, it will have an elongation, right, sir?
Which one? This one? Huh?
Sir, in the question they
Which
told that it
diagram?
is. Sir, in the question they told it is released from rest, right, sir? That time the spring will have an elongation, right, sir?
At releasing time, spring is in
Yes,
relaxed
sir.
state.
Okay,
Yes, sir.
this.
Like at mean position only, it can be relaxed, right, sir?
Why you want to change question, pa? Anant Krishna? What is your problem with your brain? It's telling is relaxed and release. No, oh, no.
Okay, sir.
Why you want to change question? I don't know. Question is given and you want to change it. Then what shall I do? Okay.
Okay, sir. Yes, sir.
Yeah, release from rest. Relax. The spring is relaxed and the system is released from rest. No, no, sir. How come it will be relaxed means then what shall I do? Okay, fine.
Yes, sir.
Read question. No, make habit of reading question.